Hey everyone, welcome. This is Tightening the Full Stack Development Loop with Nexus and Prisma. My name's Ryan, and I'm a developer advocate here at Prisma. And Prisma is all about TypeScript. We really like TypeScript, as you can probably see from even the hero spot here on our website. What is Prisma? It is probably the best way you'll come across for database access if you're working with TypeScript and Node.js. And even if you're working with just JavaScript, it works really well with JavaScript as well, but it's especially targeted towards TypeScript. And kind of the promise of Prisma is that you are going to get full database access type safety with very little work on your end. So it's a very nice tool to use if you're interested in making your database access type safe, as I'm sure you probably are since you're here at TSConf. And we're going to see how to use Prisma along with something that Prisma is a contributor towards, and that is Nexus Schema. What is Nexus Schema? It is a way to build GraphQL APIs that looks a little bit different from the maybe more traditional ways of building GraphQL APIs. And I think if the traditional ways of building them being that you would write some schema definition language. You would have a GraphQL schema definition language document which would give you the shape of your API. It would give you your object types. It would say what kind of queries you can make, what kind of mutations you can do. Nexus accomplishes the same thing, but it does it in a different way. Instead of writing schema definition language, Nexus takes the code first approach. So we write TypeScript to come up with what otherwise gets translated to the schema definition language. And right in place with it, we have our resolvers for resolving out some data for these types. So these two things together, Prisma and Nexus, they play really well together. They go hand in hand. So there's a plugin system that provides interop between them. And it works out really well. We're going to touch on the back-end pieces of imagining kind of the full stack here in this workshop. We're going to focus heavily on the back-end. But the idea is that we want to see how we can use TypeScript to our advantage all across the stack. And so if you start on your backend with Nexus as your API layer and Prisma as your database kind of management, database access layer, you get typings that you can then use across the whole stack. And it turns out that this is really nice even if you are in prototyping or development, because it ensures that you're doing things correctly from the get-go. And so instead of prototyping something and then changing things later and needing to make adjustments and running into bugs because you forgot to change something or do something, having this layer of type safety is going to be really beneficial for you right from the get-go. It also helps you when you're in production, of course, because we want to make sure that we are as type safe as can possibly be. I think that's why we all like TypeScript. Helps to give us confidence about our code and what it is supposed to do. So we're going to basically build an application, kind of an e-commerce application, if you will. I've got the application off to my left here that I've fully built out. You can actually find it over here at my GitHub. So if you go to my GitHub, it's Chenkie, my last name, and then /prisma-nexus-products. You will get the code that we're going to build towards in this workshop. So the idea here is this code is all done. We've got this working API with a working database, everything like that. I'm going to rebuild this as we go in this workshop. We're going to basically talk about what's happening through each and every step, and hopefully bring you to a spot where you're kind of confident about building really type-safe APIs, GraphQL APIs in particular, with Nexus and database access, of course, with Prisma. A couple other spots to check out as we get started. Head over to prisma.io. There's a link to the docs right here if you want to follow along with some documentation. And that, I guess, would, well, aside from maybe the Nexus schema GitHub, which is here, GraphQL-Nexus/schema. So that's probably the best spots for you to be to get started. I am going to be taking some sips of my Canadian coffee as we go, and we will get started here. I am here in a brand new directory. I've created a fresh directory here, And why don't we just get the pieces in place to get a TypeScript environment going? We're going to use tsnode-dev to give us that restart capability when we save our files. And we'll work in here. So first things first, npm init, and I'll pass the Y flag to say yes, I want to say yes to everything that's in there. And we can install some dependencies now. Let's do npm install dev. So we'll install this as a dev dependency. We want TypeScript, and we want types. We want the node types, so @types/node. And we also want tsnode-dev. That's going to be what we use to run our TypeScript project here. So we'll let that install. And then we'll want a dependency on Nexus and on Prisma as well. So we'll do npm install. This is going to now be a regular installation, not going to be a dev dependency. npm install @nexus/schema. And then we'll also want @prisma/client. So those two things will give us the ability to actually, work with our API and our database. What else do we want? We actually need another dev dependency, npm install dev, and that's Prisma CLI. So Prisma CLI, command line interface for letting you run Prisma commands that will, generate things for you, that will connect to your database, etc. And you've got a couple options. You can install the CLI globally, and then it'll be on your system. You can then just run Prisma whatever command. We recommend, though, that you actually install it locally and use npx to pick up that local install of the dependency. And the reason for that is that you will probably at some point have multiple different projects on your file system that are going to be using Prisma. And the versioning between the CLI and the client and all of those things, it's really important that they stay in sync with one another. So long story short, you don't want to have a situation where you've got a certain version of the global CLI installed, and then you've got different versions of your local projects. You want to have everything be matching in terms of version. So installing locally here is the best bet for that. So install the CLI locally. That should be good. I'm going to just check what else I have here in my dependencies in the completed project. You know what? There's a couple more. I guess we might as well do them now. npm install as a regular dependency. Let's install Apollo server. Nexus schema is a layer for you to create your GraphQL APIs, but you still need a server to actually serve your GraphQL API. And Apollo server, it's well known. It's got a lot of features. People tend to like it when using Nexus, so we can use that. So Apollo server it is. We'll hit go on that, and I think we'll get that done in a sec, and that'll be the last one that we need for now. All right, so why don't we come up with our kind of root file here, and I like to call it server.ts. So I'll touch a server.ts, and I think what we'll do to get started here, let's why don't we kind of make sure that we can actually run our server here. So we'll just have something simple in this file. So maybe a function that is called start. And we will console.log hi. And then just call start down here. And I'll zoom in a little bit here. Maybe just like that. All right. Okay, so what do we need? We need a dev script here. So in the scripts block here, let's get rid of test. We'll have a new one called dev. And here we'll say we want to call tsnode-dev against server.ts. And if we save that, now when we do npm run dev, we will get hi logged to the console there. So perfect. We have the server running. Now why don't we come up with a simple Nexus schema-based server, just an example. So we can import a couple things. Let's import the query type, and also something called make schema. And that should be good for now. We'll import those from @Nexus schema. Then the idea with Nexus is we will come up with various object types, and then we'll also have a root query type, likely a root mutation type that we define with just TypeScript. So what we can do is say const query. This will be a call to our query type that we'll then be able to pass around elsewhere. Our query type will want to have some definition for it. So this is the pattern with Nexus. We've got this method called definition, has a single param here called t, kind of for type. And the way that it works is we would say t dot, and if you just even take a look at what you get after hitting the dot, you'll get a sense of what Nexus gives you. So really nice even out of the gate here in that you are given, because we're in TypeScript land, you're given the options that you might want to work with right with autocomplete. So already, if you've got developers who are new to Nexus and they want to see like, what can I even do here? What can I define? How can I define things? You've got the options right here. Let's say we want t.string, we want to have a string type, and we'll say hello. That'll be our message. We'll want to, right in place here, we'll want to resolve with some data. So if I pass a second argument here as an object, and then I say resolve, and give that an arrow function, and I resolve with hello world, perhaps, something like that. That's enough right there to give me both my what will eventually be a schema definition language generated from this, and the resolver that is responsible for resolving data. So if you're coming from like a schema definition language based way, which if you're coming from Apollo server, for example, you're probably used to this. Apollo server, you will define your schema with the SDL, and then you'll have a separate set of resolvers. And you need to then like map those together. You'll run into errors if you have if something is defined in your schema but doesn't have an accompanying resolver. You will get errors with that. With Nexus, it's nice and tidy. Everything happens just in one place. So yeah, the query is there. That's about enough to give us an actual API. What we need to do is make our schema. And to do that, we would do this. Const schema equals make schema. And then we pass in some things. We want to pass in types. Types is an array that we will pass to, this array any of the object types or the query type or the mutation type that we define. And in our case, we just have a single type. It's our root query type. So we'll pass that. And then finally, we need to pass schema here to Apollo server to actually serve this API up. So I think we need to import it. Yeah, we do. So import Apollo server from Apollo server. And I just want to double check that I've got that import correct. Yeah, I did not do it correctly. It has to be in between these squigglies right there like that. Okay, so that's great. And then down below is where we can new up this server. So we'll give ourselves a server, const server equals what is it here? A new Apollo server. And we'll pass in schema. With Apollo server, you've got the option of either passing the types and resolvers that you might create for yourself. You can pass those in separately. Like if you had type defs, you could pass in, your type definitions, and then resolvers, same thing. Or if you put those things together ahead of time in a schema managed somehow else, you can just pass it schema. And that's what we are doing here with our Nexus situation. So then we need to listen, server.listen, and we will we'll wait until that promise is settled. We've got a port number that we'll get. And we can just do console.log server listening on, it'll be localhost port. Cool. The default port is 4000 that Apollo gives you. Okay, let's save it. And then we'll come down and do npm run dev. And the message we get is, there we go, server listening on localhost 4000. So I am getting this warning about Nexus. I'm not sure if that's something that I forgot. It is possible. We'll see in a sec. We're going to try to run this. If we go over to the browser, what you get with Apollo out of the box is something called the GraphQL playground. And if I go over to localhost 4000, I can see my playground. This is something that is made by Prisma, actually. The playground, it comes now with installations of Apollo, and it is useful for, of course, making queries to your API. All right, so if we take a look at the docs, and I will zoom in a touch here. If we take a look at the docs, here's our query that's available. Just a single query, hello, that returns a string. And so why don't we try that query? We'll do hello. If we hit go, there we are. We've got our hello world coming back. Okay, so we are proving now that we've got an API that works. That is really cool. What I think we'll do is start to scaffold out a bit of the API that's going to be used for our actual scenario here, where we've got this like e-commerce API. And one thing that I actually want to do before we start modeling that out, though, we'll kind of model it out a little bit in the API, and then we'll move over to the database perhaps and start modeling it there. But I'm going to I'm just going to copy paste something here, because this is a little bit of code, a little bit of configuration. It'll be kind of boring if I just type it all out. I'm going to copy this from my completed project. I'm going to come over here to make schema, and we can talk through it. So outputs is this object, and we're saying schema is going to be output to the directory name / this generated folder, and then schema.graphql. Likewise with typegen. So what the heck's going on here? Well, if we save it, we can get a sense of what's happening. As I saved, we now have this generated directory. If we take a look in there, we've got schema.graphql. This is the GraphQL schema definition language that is generated as a byproduct of us creating our GraphQL API with Nexus. So what's really cool about this is that if you're in an editor like VS Code here, and you're working on your front end, your React application, you can feed this schema.graphql into your editor's some extension for your editor that deals with IntelliSense with GraphQL, and then you'll be able to be in your React code, and if you're doing a query, you can see immediately what you've got available. You'll have IntelliSense right in your editor for against your API that you're working on at the same time, and they're kept in sync because this is automatically generated every time we make a change. For example, let's just see how this works. If I come up here and I put an ID in place, t.id. Oops, went all the way down. Okay, so t.id with the field is called ID, and it's of type ID. If we save that, we go back to schema.graphql. There we go. We've got ID there now as well. So a very cool feature of Nexus that gives you a lot of benefit for free. The other benefit you'll see immediately here is typings.ts. And you can probably sense what this is, given that you are here at TSConf. This is a generated set of typings for you that can be used wherever in your application stack. It gives you information about your about the things that you're creating on your API. So if you wanted to, you could go reach into this typings folder, the generated folder, get your typings, and then you could annotate various parts of your application in other places. If you want to keep things strongly in sync between your API and your front end, for example, might not always work out. It might not always be the case that the shape of your API, the typings you've got for your API and the shape that it takes on works exactly for what you want on your front end. But you get it for free, and it might be the case in your case that it would work. So have at it if that sounds good to you. Okay, so we've got typings here. We've got this generated folder. That's really cool. Why don't we start modeling out the e-commerce API that we've got? So here's what I'm thinking. We want, maybe at the top level, we want products. These are different, I guess, resources you could call them. We want products, and for a product, we'll want a set of reviews, and we will want categories. These are the three things that I think help us to see, I guess, the extent, of course not the full extent, but much of the extent of what you can get with, especially with Prisma. And the reason is that I want to go through and talk about the various kinds of relations that you can create in your Prisma models. And so the idea is that we have a top-level products resource, and we can then create some relationships between products and other things. For reviews, this would be a one-to-many relationship that we'll see. So a single product will have many reviews, one-to-many relationship. Then we'll also have a relationship between products and categories. And this one will be the many-to-many relationship scenario, which looks a little different in the way that we model it. And the idea is that many different products can have many different categories and vice versa. So those are the three things we will model out. And if we want to get a bit of a start here just with some fake data even, maybe we can start modeling out product. And we'll keep it simple for now. Let's just do const product equals, and then we need to actually pull in something else, something called object type. We have query type here for our root query. But we need for any kind of object types that we create that are not the root query type or the mutation type, that's another thing we can import, which we will use a bit later. For anything else, we need object type, and object type will create object types for us. So product will be one such thing. It all comes down to like configuration and just simple definition for these things. We need to give it a name, and we'll want to call it product. The pattern here is give it an uppercase. The first letter should be uppercase, is how it kind of, I guess, typically works in the schema definition language, and likewise here in Nexus. Then we'll give it some definition. There is that method called definition again with that t parameter. For now, let's say t.id will be called id, and I just want to give it maybe just one other field for now. T.name, that'll be a string. And that's it for now. I think that'll be it for the product. We'll put more fields in here in just a bit after we get to the Prisma side, but for now, I just want to be sure that this is going to work for us. Down here at types, I need to include product in this array. So as I mentioned, any of the things that we create as object types or anything, they need to go here into this types array. And that's going to tell Nexus schema how to produce this API for us. Okay, cool. So product goes in there. So even though we have it here, we have it defined as an object type, there's nothing that we're telling our API right now about how to get some kind of product data out of the API. And the trick with this is that we need to operate here on our query type, our root query type, and we need to tell it how to resolve certain bits of data. So in the definition block here of our query type, we could do this. We could say t.list, saying that we want to have a list of things instead of just a single thing. And then we want a field. So t.list.field, and we want to call it products. We can, create a query called products in this case. And products, the query for this has to return a certain type. So we have to point this up to our product type that we've just defined. So type is product, and then we have to tell it how to resolve. And what we'll do here is we'll say, let's return an array. And we'll just return something that abides by this simple definition we did here. ID, that can be 1, and name can be test product. Something like that. And oh, there it goes. I was getting an issue with the compiler thinking there was an error here, but it looks like that has resolved. We have restarted. So if we go back now over here to the playground, and we give that a refresh just to get our latest schema, we can do products, and we'll ask for ID and name. Let go there, and there we go. There is our data. So hopefully you can already start to see how this kind of ties together. We create a number of object types. We tell them where they should be used. For example, in this case, we want to have a query for products, and we want to say that the return type of this should abide by the shape that we've defined here, because we're typing it as product. And then we've got a resolve block just in place here that gives our data back. So everything happens in one spot, which is really cool. One of the arguments against doing schema definition language first API development, so SDL first development versus code first, is that if you're doing SDL first, the kind of traditional way, you are always hitting two places. You're hitting your schema definition language, and then you've got to go over to your resolvers and make changes there. Whereas with Nexus, it's all just in a single spot, which is nice for development. And if we take a look in generated again, check it out. Now we've got our product, we've got the two fields we defined, and on our query now, we're saying that products, when we give when we make a query for products, that should give back a list of type product. So we are in a good spot there. We're going to switch over to talk about Prisma now and how we can get Prisma wired up in our project. Prisma, when you're using it to come up with your database and to define your database shape and all that, there's kind of two core things you're going to be working with, I would say. One of them is going to be the Prisma CLI, and we installed that here. We installed it locally. Where is it? CLI up in dev dependencies. So you're going to work with the Prisma CLI. You're going to run some commands to generate code, and then to do migrations and stuff like that. And then you are also going to work with something called the Prisma schema language to define the shape of your database. So here's what we can do. Let's get a look at how this looks. If you're in an empty project, if you're in whatever project you maybe it's already created, wherever you are, you can do npx Prisma init, and that's going to run the Prisma CLI to initialize a new Prisma directory for you with some goodies in there. What you'll see off the bat is schema.prisma. It's even got a fancy logo here in VS Code. This is that Prisma schema language that I was just talking about. So it's a DSL, domain specific language. Is that what DSL stands for? I can't remember off the top of my head, but it's a DSL. We call it the Prisma schema language, so we short form it to PSL. And this is where you're going to spend a lot of time when you're modeling out your data. This is the source of truth for your database shape. It's the source of truth for how your tables relate to one another. It's where you define your tables and make the relationships between them, etc. And we can get a sense of how this works if we start to model out some data. We can define a model, and we can call it product. And the idea here is that models, as we kind of call them here, a model is going to be a table in your database. So you'll define a model, you'll give it a name, and this is going to then turn into a table in whichever database you're using. A note on databases, actually, and the support for them, there are three roughly right now that you would be considering using if you're using Prisma. It would be Postgres, it would be MySQL, or SQLite. There's support for other databases on the way. It's really just relational databases right now. Lots of demand for NoSQL databases to be supported, like Mongo, for example. That is further on. That's on the roadmap, but it's further out. But right now, yeah, Postgres, MySQL, SQLite, those are the three. There's support for other varieties of SQL of relational databases coming. But yeah, it gives you a decent amount of options to start with. Okay, so we'll see in a second how to actually connect to the database, but I want to start by modeling out the table for our product. The field that I typically always start with is my ID field. ID in your database, you probably have a sense of what this is. Sometimes you might have an integer ID field that auto increments. If that's the case, you would call it an int. ID would be an int. If you wanted it to be like a universal unique ID or something like that, you'd probably want a string. If you want this to represent your kind of primary key for your for this table, you would use the add ID decorator. And then you've got some options here as to how the behavior is defined. You can say that you want a default value for your column. And in my case, I want to use a UUID. There's another option. You could use a CUID, which is I guess a collision resistant universal ID, but UUID is what I usually reach for, just to make sure I'm completely collision free. And yeah, so that's how you would do it for your ID field. If you wanted to have an auto incrementing field, I can even show you. Maybe what I'll do is come down here and make another model just to give you a chance to compare. You do ID instead of being string, I'd do ID int. You'd mark it as ID, and you'd say the default would be auto increment. So there's this auto increment function. So that just, it does kind of what you think it would do. Every time a new record goes into the database, it will auto increment based on the existing integers that are in that column. So two ways of doing it that are typically seen. I usually stick with this one, but other people like to do ints instead. But we'll stick with this. Okay, so ID. What else do we need? I'm going to pop open my completed Prisma model over here. So we've got ID, and then we'll have name. Name is going to be a string. What else do we need for a product? A description. That's going to be a string as well. We'll want a price. And in my case, I'm going to set that to an int for price. It could be a float if you wanted it to be. But I've run into issues before in applications that I've made that deal with currency where it's like, if you set it as a float and then you have a price like that, at some point, if you're doing math on this currency, this is going to run you into trouble because of floating point issues and whatever. I don't necessarily understand all the varieties of how calculations can go wrong, but they can. And so I think the advice typically that I've seen is set it as an integer. And so then instead of having $50 like that, you would just have 5,000 cents. And then on your front end, you can just do the math to convert this. So it's a much cleaner way of working with currency. And I think if you're working with the Stripe API, if you're using Stripe in your application, they're going to give you values in cents anyway. So at least that's the last that I remember of using Stripe years ago. So we'll set price as an integer. We'll want a SKU. That can be a string. And SKU is the thing that identifies the product, I guess. I can't even remember just now what SKU would stand for. But it's the thing on the product that gives it a unique sort of identifier in the product world. And what we could do is we could say we want that field to be unique. We've got this unique decorator that says if I tried to enter a new product that had a SKU that is the same as one of the products already in the database, then it's going to throw an error. We won't be able to insert that data. So that's very useful. What else? I think that's probably good for now. We're going to do a couple more things here, but that'll be in a little bit once we start getting some other data in. You'll notice as I saved there, so I did Command S to save, it formatted things for me, and that is a feature of the Prisma VS Code extension. So if you go to your extensions and you search for Prisma, you can find it there. It's what will give you the syntax highlighting, the autocomplete that we've seen, the formatting. It's going to give you all of that really nicely here within your .prisma file. Okay, so this is our first table modeled. Very cool. What we need to do now is think about our database. So if you take a look in the environment file, .env, it gives you a database URL off the bat, which is a Postgres database. I've got Postgres here on my system. We could use this, but I think what we'll do instead of using Postgres, let's use a SQLite database. It's a little bit easier to I guess it's a bit easier in some ways, especially for our demo here to work with. To do so, you can just come in and create a new file, call it dev.db. So dev.db will be our SQLite database. And then in the data source here, we can say provider will be SQLite. And instead of pointing the URL for the database to that environment file, so this .env will go into the .env file and look for our database URL. And so you can create other variables here as well, and then use them in your Prisma file with env. But instead of doing this, we are going to just use the file system. And to do so, it looks like this. The URL is going to point to file : and then dev.db. And that's about it. So now our database is going to point to the file system here. Cool. Okay, so we'll save that. What else do we need to do? I think that's about it for our definition. But what we do, we've got our database, but we don't yet have it like situated as it needs to be to know about the shape of our data. So we need to give it a table, for example. We need to create that table in our database. To do that, you've got a couple options. You could go in and create your table manually. That's totally fine. Or you could use Prisma Migrate. Prisma Migrate is a tool which generates database migrations and runs them for you. It's the way that I prefer to do things. It's much simpler. I'm going to give you a caveat with it, though, which we'll see here, is that it's experimental and it's subject to change. But you can go ahead and try it and use it. There's lots of people using it successfully. To use it, you do npx prisma migrate, and we need to save a new migration. And then we need to pass experimental to say that it is that we know that it's an experimental feature. Name of migration, we'll call it init. And that looks like it ran for us. Very cool. We are over here. We see migrations. We see the migrations directory that got created. And this subdirectory that's got I guess a date stamp with it. If we take a look in the README, here's the set of database steps that it is telling our database to run. Create table product, set these fields, etc. Primary key is ID because we marked it with that @ID, the @ID decorator. So this gives the instruction to our database to do the things that it needs to do. And as we can see here, run Prisma Migrate up experimental to apply it. So let's do that. We'll do npx Prisma Migrate up experimental. And if we do that, we should now have our migration complete. And we will have that table in the database. We can't really, we can look in this file. It's all just kind of, gibberish in a lot of ways because it's just, the SQLite format here. We can view this database by going into like something like Table Plus. I've got Table Plus on the Mac here. That's a good way of viewing the database. But another feature of Prisma that gives you maybe an even better view into your database would be to do this, npx Prisma Studio. Prisma Studio, another feature, another product, if you will, that that gives you what is kind of how we refer to it is it's a more modern PHP MyAdmin. So let's see here. Localhost *5 takes us to Prisma Studio. Our single model that we've got right now is product. If we go in here, there are no rows in the table, but this is our database to look at, basically. Okay, so why don't we get some data into our database via Prisma? If we go back over to our code and we take a look over here at our server, right now product, it has two of those fields that we define, but we need a couple more. We need description. So description was another field. We had price, t.int. That's going to be price. We had t.string for SKU. Those are the fields we have right now. And cool, I think that is about it. All right, so we want to have a mutation now so that we can actually get some product data in here. We've got mutation type coming in. So what I need to do is say constant mutation is equal to the mutation type. And that's going to have some definition. this is the pattern that I'm sure you're getting used to by now. We give it definition. And then we want t.field. We want to say create product. That's going to be the name of the mutation. And it looks a little bit different, I suppose, at this point, because we need to take some arguments in. We need to take in some arguments for the shape of our data. And there's a couple options for how we do this. I think the advice in the GraphQL world is if you're going to be taking in many different fields as arguments, you should put them on a single input type. We could do that. I'm just going to put them in place here because it's a little bit easier for now, but you can feel free to do this in a bit of a different way where you just pass a single input object type. Args, we need name. That's going to be a string arg. We get this import from Nexus schema called string arg, and that just tells Nexus that this is a string. We also need a description, string arg. What do we need? Price, that's an int arg. So that will just make sure to import it. Yeah, int arg is there. We need skew. That's a string arg as well. All right, cool. We're getting red lines here because we need to give it a return type. The return type is going to be a product. Cool. And then we want to resolve this. So args are there. Resolve goes here. And if you are familiar with mutations kind of in the typical way that you would do them, you'll kind of remember that the resolvers have 4 arguments. There's parent, there's args, there's context, and there's info. Those are the 4 arguments that you get in your resolver functions. In our case, let's do this. We'll do parent, and we will do, let's destructure out all these arguments: name, description, price, and skew. So those will go there. We don't need context right now. We'll see how to work with Prisma directly. Okay, so why don't we? I'm just going to return an empty object, I think, for now, because I want to get to another spot that we need to get to, which is going to be to bring in Prisma, the Prisma client. So I just wanted to set up the mutation for now. Here's what we need to do. We need to close down that terminal. Oh, I guess doing so just killed my Prisma Studio session, so actually we don't want to do that. Let's do npx Prisma Studio once more. All right, cool, so that's back up. What we need to do as a last step to putting together our Prisma database is we need to do Prisma generate. So this command, npx Prisma generate. This command is going to take our data model that we've defined in schema.prisma, and this is the really cool spot where TypeScript comes in. It's going to take our data model and it's going to run a bunch of code that is then going to place into the node modules directory, and into the .prisma directory, it's going to place typings for our Prisma client. So if we search for type product, check it out. We have a type exported that is the model for our product. And the way that this works is that these typings are used for the Prisma client, which is like that ORM sort of thing that we'll use to tell it what we can and what we can't do for our database. Like basically what we can query for, what we can insert, etc. So we're not guessing, we're not going to our definition for our database to check out what types we have, what we can insert, etc. It's all typed for us right in our editor, which is super nice. This is probably one of the biggest benefits of using Prisma amongst many others that it has, is that like when you go to operate on your data, it is very clear what you can do and what you can't do. So super important. So we've got that in place. We're generated. Now we need to import Prisma client from @Prisma client. Oops, client. There we go. Okay, so we've got the import and we need to new it up. We'll give ourselves a constant of Prisma is a new Prisma client. And now, even if we just take a look right here, if you check out like Prisma and then do dot, we've got our options. A number of methods that are like Prisma methods for connecting and disconnecting if we want to do it manually. doing raw queries, etc. But down here, we've got this property called product. And if we take a look at this, we can see what we can do. We can query for products by finding many, finding one. We can create new ones, etc. And then like once we tap into these, we've got our further types for what we can actually pull out of the database. So it is super useful. We'll put it into play right here. Let's do, we will return prisma.product.create. The create method takes an object. I guess first thing that we'd want to pass in is data. And if we take a look at this, if we open up a new object to say what's going to go in, and we do control spacebar, here it is. We've got the things that need to go into the database here. ID is optional because it's going to be auto-generated for us, but the others are not optional. These need to exist. So this is going to stay red here until we give it everything that we need to give it. So for example, we can say name has to go in there. We can say description has to go in there, and price and SKU. And now it is satisfied. Data is satisfied. But if we take out SKU, boom, we need to do something to fix the issue. And of course, that is to put in SKU. And I think we can get a sense of like how this works together. If, for example, let's change price to be a string arg. Is that going to pick up? I was thinking it may have picked up the fact that price has the wrong type. Maybe if I save. It's typing it as any, just coming in through here. I wonder if there must be a way to do that though. I wonder if I take args like this, so that here's some real-time sort of me exploring around. If we do args.name, args.description, I don't know if it's going to work. args.price, it's probably still just hinted as any. Yeah. Anyway, I think I've seen it before that there's a way that this actually gets picked up. It may require further configuration between Prisma and the Nexus schema, but there is a way to say, oops, I'm giving it the wrong type here, and to catch it at the time you actually try to create that query. Nonetheless, we will change that back to an int arg. And we can save this now. I think we're good there. Let's see if this works. Let's go over to GraphQL Playgrounds. I'll bump this up a couple more shots just to make sure everybody can see it. And now let's give ourselves mutation. And it's create product. Oops, I'm seeing what I'm forgetting here. Mutation is defined, but it's not used. So mutation, we have to put it into our types array. So query, mutation, and then product. All right, once more, mutation, create. Is it still not showing up here? Let's see, what's in the docs? Products. Wonder what's going wrong. Let's go over to here. Mutation type, T field, create product. Oh, it looks like it just didn't save. The file didn't save for some reason. Let's try this again. Docs. There we go. Create product is now in there, which means if we come here, we can do create product. Awesome. So name, that's going to be coffee maker. I got to get rid of that pop-up somehow. Coffee maker. Description. Let's prettify this. Maybe we can't yet. Prettify? Huh, I wanted it to bump down to a new line, but whatever. The best coffee maker. What else do we need? Price, 5,000 cents. And SKU can just be like 1, 2, 3. Let's return the ID and all the rest. Cool. There we go. Bumped everything down now. Okay, so hit go, and boom, create product returns an ID. It returns this UUID that tells us that it actually inserted it into the database. And in fact, if we go and refresh here, there is our very first record. Okay, so we've got a single product in. We can also, if we now do a query for products. Just get like ID and name, for example. We've got our, oh, we need to switch up, of course, we need to switch up the query here to use Prisma instead of just returning this hard-coded data. Here, it's super simple. This will give us another sense of how to use Prisma. We do return Prisma product find many. And so you've got options here. Like, so let's run this. I'll just save that and we can run it. There we go. There's the actual record from the database. Find many gives you a bunch of options. And the cool thing, of course, because we are in TypeScript, is you can do Control Spacebar. And you can do things like take a certain number of them. You can skip. So if you're doing pagination, this will, these two will come in handy for sure. Select certain fields. So if I wanted to say select, if I wanted to do name true, let's see how this works. If I do that, yeah, so name ID true. There we go. So yeah, in this case, the data returned from the database is going to be only these two fields, ID and name, even though there are other fields in that table. So lots of options for querying data out of your database with Prisma, but this will do just fine for now. We'll do the find many. All right, so I think what we'll do now is we will take another of the tables that we've got. I'm just checking out my schema.prisma file to see what we've got. So I think what we can do now is go on to modeling the reviews. So we talked about how we want products. So we want to have products, reviews, and categories. So let's go over to schema.prisma and we'll make a new model. Model review. We'll call this one review. It's going to have an ID just like we did up here. Same thing. ID will be a string with the default of UUID. A review should have a title. That's going to be a string as well, and a body, which will be a string as well. So in its current state, you can probably see what we would do. We would go and migrate the database again. We would then have our reviews table, but there would not be a way to connect products and reviews together in the current state that we've got it right now. So what we want to do is we want to relate these two things with one another. The way that I think about it is like, okay, I think about the kind of relationship that I want. It's a one-to-many relationship between product and review. So one product has many reviews. And then I say that I want to have a certain key on my products table called, or my products model, I guess I should say, called reviews. And reviews, the way that this works is we can point it, we don't have to use one of these scalar types here. We can point a field to another model in our Prisma model. So we can say reviews will point to our review model. And since we want this to be a one-to-many, we want there to be many reviews, we can put in the square brackets right after, which tells it this is going to be a list. There's going to be many reviews here. So that's in place. And there's some work we have to do on the review model as well, but check it out. If I have the extension, the Prisma extension installed, and I just hit Command S for Command Save, the work is done for me. This got auto-populated by Prisma, which is very helpful. It saves a lot of time, and it's a lot of typing that is saved for you. The way that it works here is it's going to, there's two things at play when it comes to the relationship and how it exists in the database and how it exists in the Prisma client. The product ID that gets inserted here, this is a field that's actually going to be populated into your database, and it's a string field. However, this product field here is only used in the Prisma client to give it a way to know how to operate on your data, your two tables, how to pull data out, how to connect them, etc. This field here does not exist in your database. It's only in the Prisma client that you'll see it. But product ID here does exist, and this is your relationship between the review table and the product table. So product ID is going to point to this ID in the product table, and that's how you do the relationship. All right, so because this gets uppercased by default, I like to have some consistency, so I will change it to a lowercase p. And I'm going to say that these are, I'm going to take off that question mark. This means that it's like an optional thing. I'm going to say that this will not be optional. We're going to have this in there. So we can have 0 reviews. That's fine. I'm just going to say that the field itself is required. Okay, so let's save that. And with that in place, we can go and migrate our database again. So let's open up a new terminal. We'll do npx prisma migrate and save experimental. Create review is what we'll call that migration. And then npx prisma migrate up experimental. Cool, the migration is done. And then finally Prisma generate to make sure we get our types generated. npx Prisma generate. Awesome. So we have things working for us now with our reviews. So how do we get a review into the actual database? That's probably what we can work on next, I think. I'm going to take a look at my code here. Yeah, let's do that. Okay, so over here in server TS, let's go to our mutations, and we've got one created right now. It's a create product. Let's do one for creating a review. So here we can do t.fields, and we'll call it create review. Then in here, we need to give it a type. And of course, I kind of jumped the gun a bit because we don't actually have a review object type yet. Why don't we create that first? So kind of like we did for product here, I'm actually just going to copy this. Actually, no, I'm not. I'm going to come down here and say const review equals an object type. The name is review. And the definition looks like this. We want to have an ID. We want to have a string field, which is going to be the title. And then we want to have a string field, which will be the body. I think that's it. We'll see how this all works together. Yeah, that's it for that. But we do actually need to modify the product object type so that it has a review field. We can just kind of shim that out for now. It's a t.list.field called reviews. And what you'll see here is this is kind of an interesting. This is what's interesting about Nexus is that like these ways of doing lists and fields and nesting them, it can go all the way down. Like you can be at the root query and mutation type, and you can be returning lists and fields and stuff like that. But you can also do the same thing on your object types. So right within an object type here, we can have something that looks like it's at the root query type, where we have, the type is review that we want to return, and we have some we have resolve for it. And we can go and hit the database here to get this information. Let's just return an empty array for now. All right, so create review. Type is review. Let's give it some definition, or what am I doing here? Let me just take a look at the code that I've got so I can remind myself. Right, I want to take some arguments. That's what I want to do. So args, we've seen this before. We'll have title. That will be a string arg. And we'll have body, and that's a string arg as well. Cool, so args will be there. We need one more, and that's going to be product ID. That's a string arg as well. The idea is that we'll need to connect this review that we create to a product to relate those things together. So we can resolve, and we can take our parent, we can take our args, which will be destructured here, title, body, and product ID. And then in the body here, let's return Prisma review. And it looks like I actually have to, maybe got to restart the TypeScript server. Sometimes it doesn't pick up the changes right away. I'm actually not getting review in there. Return Prisma dot, so I've got product. Do I have a file that's unsaved here? Server.ts is unsaved. If I do Prisma generate again, should be there. Restart TS server, return Prisma dot. Interesting. Well, let's double check the schema. We've got review here. Did we get a migration for it? Yeah, review is there. What if we were to go look in our Prisma Studio? If I refresh that, I think I actually need to, for Prisma Studio, I've got to restart it. So let's do npx Prisma Studio. There we go, review is there. So why then, for the Prisma client, am I not getting it reflected? Prisma dot, there it is. So, okay, it's there now. I'm not sure why it wasn't showing up down here, but it's there now. I've found that when working in VS Code and like things are changing in TypeScript, it's always hit or miss as to like when the change gets reflected. I'm always doing this like restart TS server command to restart things and give it a kick. Anyway, let's try this again. Return prisma.review.create. So just like we created a product, we want to create a review with some data. What goes in? Well, we need the body. We're getting that from our arguments. We are going to need title. And then what do we do with product ID? When we're working with relations here with Prisma, it looks like this. We want to connect it to a product. So we do product, and then we do connect. And then we say point to the ID field in the product table and pass, well, I guess what I should say is connect them via the ID field that exists in the product table and make that the product ID that gets passed in as an argument here. Okay, so those will connect now. And what I can do, so we're returning that review. Why don't we, we'll give this a shot. We need to make sure that review goes down here, or I guess I'll put it over here near product, maybe after product. Review can go there. Are we still good here? I'm getting this error here still for review. Run dev. Missing review. Did you forget to import a root query tip? Yeah, once again, I'm hitting Command S, but sometimes it's not picking up my commands to save. I don't know what's happening there. So anyway, it's because I didn't have the file save. But now we've got it good. So review, create, etc. Let's go to, I have to reconnect that in a sec. Let's go here first though. We'll get our latest schema. Create review exists, perfect. So let's try this out now. So we'll do a mutation and we'll call for a create review. We need title. That's going to be the best coffee maker, and body. The coffee was so good. You can probably tell that I really like coffee. I've got my Canadian Tim Hortons coffee here. Coffee was so good. Product ID. What the heck do we put in for that? Well, if we want to connect this to the existing product that we have, we need to grab its ID. Why don't I open up the studio again? I accidentally shut it down. npx Prisma Studio. Oops, wrong command. Okay, so reconnect. Over to product. We grab this ID. So let's grab that product ID and let's pass it into our arguments here. And then so once the review is created, let's get back ID and title and body. Cool, so we've got a review. We can confirm that if we go over here to review and refresh. We've got our review in place. And the product ID, of course, points over to product. So what's cool here is that if we want to do this query now for all of our products, we had products like this, we had ID, we had well, I guess we could do name and description. Let's just get those. Okay, so there's the product. If we wanted to do reviews, and it looks like I spelt it incorrectly over in our code here. Yeah, I did. Reviews. going to have a type of review. Right now it's returning nothing. We can run that actually. Let's take a look. Reviews. And so right now it returns an empty object. But if I did this and I had, let's do this. If I took out this resolve block here, if I just comment that out for now, and then I come down to my query for products, where did it go? There's create product, there's the mutation. Here it is, products. If I do a find many on product and then I do include, if I pass include and I say reviews true, if I want to include those, now when I go over and I hit go, there it is. I've got my reviews coming in as well. I was trying to get this to show a bit better, but it looks like it's not going to. Reviews will be coming in. So there's a bit of an issue with this way of doing it though, and that is that if I'm not interested in my reviews, since I'm working with GraphQL and I can ask for exactly what I want, if I am not interested in getting those reviews, I'm still doing the lookup in the database for them. So not super efficient because it's data that I don't need. I'm effectively overfetching from the database. A way to get around this is instead of including reviews true here, instead of doing that, what we can do is come up to our definition for our product, and in the reviews list, I can resolve with data at this point. So what that looks like is I need to reach into Prisma and look for the reviews that are related to this product at this point. And it's only if reviews are requested now that we will actually get the reviews coming in. So what does that look like? Well, we need some information to drive that query, and we need to get some info from the parent query. Parent is going to have the arguments that we pass to the parent query, which will be useful in this query here. So, for example, let's do parent, and let's see how this works. Let's console.log parent. We'll go over here, and if I hit go on there, I guess I have to ask for it. Reviews. If I hit go, what I get from that parent that I just logged to the console is I've got this ID. This ID is it's the ID that belongs to the product that I've gotten out of the database. So what I can do now is I can use this ID to say, hey, go get the reviews that are related to it. And what that looks like is I can return Prisma.review find many. I want to find many reviews where, so we've got this where clause, and where what? Where product ID, which is an option here, where that's equal to parent.id. I want to pick up the parent ID there. And now I want to send back those reviews. So, boom, there we go. We are getting it passed back to us. So that's great, because now if I'm asking for reviews, I'm doing those two separate kind of query operations. But now if I don't ask for reviews, if I just want this information, then I'm only getting what I'm interested in. So that is beneficial. Okay, so now I think to finish things up, let's look at categories. This is going to be a situation where we are doing a many-to-many relationship. And what we're doing with a many-to-many relationship is it's going to look a little bit different in the Prisma model. Why don't we go model this out quickly here? So schema.prisma, we can do model category. And if we remind ourselves what's a category, it's just like a tag to put on to a product. It's a way to categorize them. And we picked this one in particular because many different products can have many different categories, and I guess vice versa, right? So this is an example of a many-to-many relationship. We'll give it an ID, a good old UUID, the one that I like, default to UUID. We want the category to have a name, and so those would be the only, I guess, attributes of the category. And then to set up the relationship, this is what it looks like. We say product is going to have categories. So a single product can have many different categories. And so we can say, and then ultimately many products can have many different categories, but the field that we'll operate on is called categories. That's going to point to our category model and say that there can be many of them. Then conversely, down here in category, we'll say products, and we'll point to our product model. So now we've got this kind of like dependency between product and categories, or this relationship, I guess you would say, between product and categories. And if you're familiar with the way that many-to-many relationships are modeled in the database, you'll probably be familiar with how we use like a pivot table. So we have our product table, we have our categories table, and then the way that we relate them together, because it's a many-to-many relationship, is we have this pivot table, this intermediate table that tells us what relates to what. The way that you are going to use many-to-many relationships as far as your database is concerned with Prisma, it's one of two ways. You can either do it implicitly or explicitly. So what I mean by that is you could come down here and you could say, I want to model out my my pivot table. You might call it like category, category on product, something like that. And then you would say, okay, I need like a product ID, I need a category ID, etc. Like you could set things up this way, but you don't need to if you don't want to. Prisma, if you just set up your relationships like this, Prisma is going to take care of all of the necessary stuff, including creating a table for you, your pivot table. All of that will be taken care of for you. So it's less work for you. That's the way I recommend, but there may be reasons why you want to create your own model for your pivot table. Nonetheless, we've got things in place now for our many-to-many relationship. So let's go through the steps again. npx prisma migrate and save, and it's going to be called create category. Sorry, that comes in after. Experimental create category. npx prisma migrate up experimental. Cool, that's done. And then npx prisma generate to generate the client. Boom. And we're done with that. So server.ts is where we can go and start to model out the category. So taking a look at what I've done here, it'll look like this. We'll do const category equals an object type. We'll give it a name. The name is category. And then we need to give it some definition. What do we have? We have an ID fields. We have a string field, which is name. And then what we'll have is a list of products on this object type, because we have this many-to-many relationship. We've got products having a list of categories and categories having a list of products. So these can we can get information about the other one through the original one, if that makes sense. So through categories, we can get information about products, and through products, we can get information of categories as far as they relate together anyway. So that field is going to be a list, and it's going to be called products. And the type that will be assigned to this return is a product, and then we'll resolve with some data here. We'll need the parent. The parent's going to give us information about what's on that query. And we will return Prisma dot category. Sorry, we're doing products here. Return Prisma product, find many, and we will find many where, and this looks a little bit different. We'll do categories, and then we'll use the sum operator. We've got this like sum property operator, if you will, where sum and then ID points to the parent ID. There's different ones of these, like you've got sum, you've got every, you've got none. In our case, the way that it works is we'll use sum, and that's going to point to the ID. Okay, cool. So that should be good to go. I will just double check here what I'm doing on the product side. So product will have a list as well. t.list.field categories will be the return there. The type is going to point to category. And this will resolve like such. We will say, we'll get the parent for ourselves here, and we will return Prisma dot category dot find many, where products, in this case, every ID points to the parent dot ID. Okay, that should give us our categories. So let's see, I gotta include category down here, review, category. And we need to, we actually need a mutation, I guess, to create the category. Let me see what I did over here. Yeah, I've got two mutations here to create the category. One is to, the one that I came up with was to create the category initially, and the other is to then categorize the product. So kind of in two separate steps. So let's see what that looks like. We'll do a new field here on our mutation. I'm just going to double check that I'm in the right spot though. Am I in my mutations? Yep. So t.field create category. And that's going to return a type of category. And we'll need some arguments. We'll have a name. That's going to be the only thing, string arg. Cool. Then we will say resolve. And we'll get the, so there will be parents, which I guess like some people, usually when you're at the root types, like mutation, the root mutation or the root query, you would do like an underscore just to say that there's nothing above this. But you know, you can still do parent. And then we'll get the name from args. And then the way that we insert this into the database is what we've seen before, Prisma category, category create, and data goes in there, and we need to pass in name. Okay, so that's to create the category. And what's the issue that I'm getting here? Does not exist on the Prisma client. I'm getting that issue again. Restart TS server, I guess, maybe. Prisma category, it's there. Create data name. Why is it saying doesn't like it? Doesn't exist on the Prisma client options. npx Prisma generate. Back over here. Restart TS server. Save. Is something unsaved here? No, I'm not sure why we're getting that error. Let's see if it works. We're going to use it anyway. I'll restart this. No, because it's not running. Oh, you know what? Maybe it's an issue further up. Find many products. It's not assignable type product. Where input? Huh. Okay. Maybe I've got an issue up here. Category. I'm just going to comment this out for now. See what we can do with this. So return. There we go. If we do that, we're green. If we do this, we are not green. Okay, so the issue is here. Let's leave that for now. Let's start by creating a category, and we'll get this working in a sec. Mutation. Create category. We'll need some arguments. The only argument is name. We can create a category of kitchen stuff, something like that. Pass back the ID and the name, and hit go. There we go. It's now in there. What does Prisma Studio say if we refresh? And no. I always forget that I've got to regenerate my Prisma Studio, which I don't know if there must be a way to do this. I don't know what it is, but have it done automatically. npx Prisma Studio is now back up. We've got our category, and we've got that single record for kitchen stuff. So Oh, I think I'm saying, yeah, I'm thinking now the issue here, the TypeScript issues that we were getting, it's probably because we don't have the relationship established yet between products and categories. We need to do that first. And so for that, we can actually categorize the product before we try to query for it. So we've got create category. Let's do another mutation, t.field. We'll call it categorize product. What does this return? We will return a product from it. And we will resolve like this. Actually, before we resolve, let's do args. We need to take in some arguments. We need a product ID, and so that will be a string arg. And we need a category ID. So just those two things will give us enough information about what to pass in to our Prisma client to actually to create that relationship. So args goes there. So parent. And we'll want product ID. I'm missing something here. Yeah. Arrow function. And then this can come over. Parent. We'll want product ID and category ID. Cool. Okay. So that should be enough. And it looks like this. We return Prisma product. And we'll update the product. And we will update where the ID is equal to product ID. Cool, so that's targeting a certain product. And then we'll pass in some data. And the data, so typically if you're doing an update on like something like your product model and you're updating the name, for example, you'd pass data, you'd pass name, you would update your new name, etc. But in this case, we need to make the update to connect the category and the product together. And so it looks like this, data categories. We need to connect, and we say the ID that we're connecting to is the category ID. Cool, okay. So let's see, are we running here? We still are. So why don't we try this? Let's go over to the playground, we'll refresh. And we'll say categorize products, and then the arguments that we need here will be this. We'll need product ID and category ID. And product ID, let's see, let's go to product. We'll just copy over this ID. Obviously, this would be done through some kind of user interface if you were, if you had your front end going, but we can just stuff this in by copy and paste. So let's hit go. Okay, so we got our product back, so it looks like we're good there. If we refresh here, and actually, let's see, if we, yeah, there we go. So if we refresh here, we get this little thing here, product. If we click there, we can see the related products. So that's one of the really nice benefits of Prisma Studio, is it gives you these relationships and how they work together very nicely. I think we get the same converse, yeah. So here we get categories. We can click into the category that we are categorized against. Okay, so the final thing is to go and revisit that like query that kind of broke things for us a bit earlier, and that's up here. Let's uncomment this. Let's see if this is going to work for us. We're good to go now, so I think this is going to work. Let's see, maybe we can do, got our mutations. Do we have a category? So we got create category. Maybe we can do a list of categories. t.list.field categories. This is going to be to get the categories out in a query. Going to return a type of category. And we will resolve by doing return Prisma category. We'll just do find many. Okay, so let's save that. Let's go back to the playground. And let's do categories. Do ID. Do name. kitchen stuff. Cool. What I want to do is get products. Which products are assigned to this category? Let's get the ID and the name of the product. If we do that, we get our coffee maker. So these things are related now in the database, and we've got the relationship established to get data back about these two things. We can also do the same with products. Let's see if we got this set up properly. If we query for products and we ask for ID and name, and then we want to get categories, ID and name for categories, does this work for us? Something's broken here. Yeah, there's the inverse, basically. We have our coffee maker product and then the categories that are assigned to it. Okay, so there we have it. We've got a Nexus-based GraphQL API. We've got a Prisma-based database going. These are all totally type safe. So, like we've seen, the benefit here is that if you're trying to do something in your database that's not allowed, it's going to tell you about it. Your program is not going to compile unless you are doing the right thing. So that's super beneficial because, I know I've wasted a lot of time and there's been a lot of heartache doing queries that are not quite right. And so if there's a way to make that faster and give you more confidence about it, take it. That's what you get with TypeScript, of course. That's what you get with Prisma and Nexus. So if you like what you saw here, take a look further at Prisma. Tons more features, tons more to come. Things are really cool at Prisma. There's a lot on the roadmap that's coming that's going to be great for your workflow. So check it out further. Check out Nexus. It's here on GitHub. I think the link to the website is probably here somewhere. Yeah, you can check this out. This is probably the spot that I would guide you towards to check things out. You can find me on Twitter. I'm at Ryan Chenkie on Twitter. And if you want to say hi there, please feel free. Happy to help you out with anything related to Prisma or Nexus or anything, really. If you have any questions about things beyond, feel free. Thank you for being here today. And I hope that you have fun with Prisma and Nexus. All right, bye-bye.